Hello everyone, welcome back to Diksha Karnataka YouTube channel. I hope you enjoyed your Christmas holidays, and currently I think it is continuing with the Christmas holidays and New Year holidays. So I hope you are enjoying that. And right now we are back with the BRAHMASTRA series, next topic of physics, that is nuclei. As I said Tuesday that I will be doing nuclei on Friday, so I am doing this chapter today. Let's see what all is there. So this is the weekly schedule. Maybe there are slight changes because of the Christmas, otherwise the schedule is obviously the same. Now if you are studying in second PU, then you must have heard about this PU 2 success blueprint test series, one of a kind test series offered by our channel to all the students who are currently studying Karnataka second PU, right? And what all you get? You will get 12 mock tests, 4 part and 8 full syllabus. Mock tests are already going on, so if you want, you have to purchase it today. Subject covered PCM and biology and CS, everything is covered. Also exam focused question paper with PDF solutions, and moreover you will get a video solutions from all the teachers. We will explain the questions difficulty level as well as the answers to the questions, okay? And any doubts that you might have from the question paper, we will come and discuss about the doubts as well in a live session. And the price for that is 599, but there is a surprise for you. If you use my personal code, which is SAM100, you will get this for only 499. The offer is valid till tomorrow, 28th of December. If you are watching after 28th of December, then this offer is no longer applicable. So you have to wait more for some other offers to come. But right now this offer is applicable till 28th of December. You can apply this coupon code and get this discount, Christmas discount. Christmas is over, but Santa is still here. I am your Santa. You can use my code to get a flat 100 rupees off. Now let's see the chapter blueprint. So as you can see, all the blueprints are giving 4 marks from this chapter, 1 MCQ and 1 short answer type 3 marks question, and one of them, the first blueprint, is giving you a numerical question, numerical problem. So there is a high probability that there will be a numerical small 3 marks question will come from this chapter. So we will be doing that. And what are all there in the chapter? You will get 15 MCQ questions and 5 3 marks question, okay? There is no 2 mark question, there is no 5 mark question from this chapter, not at all. There is no possibility, only 3 mark questions will come from this chapter, and the 3 mark questions are very limited. So numerical questions sometimes is very common from this chapter. Last 2 years, that is 2023 and 2024, the questions from this chapter was a 3 marks numerical, okay? So we will be solving some numericals from this chapter. Now let's see the MCQ questions. MCQ are relatively easy. Sometimes a little bit of thought process is required, but it is quite straightforward. Among the following, which set of nuclei are isotopes? So isotopes means nucleus of same element but having different mass number. So the same element means their atomic number has to be same, but the mass number has to be different. So this is easy to remember, right? So here you can see only one thing has, one pair has same element. So that's it, you don't need to look for any other options, okay? This is from one of your previous year model question paper, not sample paper, previous year model question paper. One of the previous year model question paper has this question. So this is the answer to this question, okay? So because just by looking at it without even knowing basic concept of isotope, you can answer at least this type of questions, okay? Because isotopes means they will have same atomic number. So atomic number is same and mass number are different, okay? There are different isotones, isobars. If you know them, don't forget to mention that in the comment below. What is an isotone, what is an isobar, okay? You have learned that in chemistry. Next, The radioactive decay in which very high energy photons are emitted is called. So, there are three radioactive decays majorly. One is alpha decay, another one is beta decay, and there is a gamma decay. Now, in beta decay there are two possibilities. One is positive beta decay, that is a positron is getting emitted, and there is a negative beta decay, that is an electron is getting emitted. Now, what is alpha decay? Alpha decay is when an alpha particle is emitted. So, alpha particle is not a photon, it is a helium nucleus. Beta decay is electrons, both decays are either positron or electrons. So, that is also not photon. Only photon associated with any kind of decay is gamma decay. So, answer is gamma decay, not alpha decay, not negative or positive beta decays. Okay. So, only answer is gamma decay. Gamma decay is basically when nucleus emits extra energy in form of electromagnetic radiation. Okay, some high energy radiations comes from this nucleus. Now, the ratio of nuclear density of aluminum and copper is. So, this very interesting question, very misleading question in terms of difficulty. Okay, you might find, okay, I have to calculate the radius, I have to calculate the radius, from there I may have to calculate the density. Actually no, the nuclear density is constant. The only logic to answer this question is the nuclear density is constant. So, their ratio will be 1:1. As simple as that. This is a very simple question. Okay, nuclear density, ratio of nuclear density of any two molecules mostly will be 1:1. There are certain variations, but 99.99 cases the nuclear density is constant. Okay, or even if they are not constant, they will decay and try to achieve that constant value. Okay, the value is given in your book, you can check there. It is a very high value. Okay, not normal for normal materials. Okay, because nuclear is densely packed, its density is super high. Okay, and it is constant for all the nucleuses. So, all the nuclei. So, the ratio is constant. So, does not matter what is the mass number, nothing to do with mass number. Nuclear density is constant. The nuclear force is, this question is from 2024 question paper, 2024 this question came. Attractive for distance 0.5 femtometer, attractive for distance less than 0.8 femtometer, repulsive for distance 0.8 femtometer, repulsive for distance are less than 0.8 femtometer. Okay. So, if the distance is 0.8 femtometer, then this distance is less than 0.8 femtometer, it is attractive. Okay. And if the distance is the force slowly, the repulsive force slowly starts to take over from 0.8, and when it reaches about 1.2 1.5 femtometer, it is completely repulsive force that dominates it. Okay. But in the range of 0.8 femtometer, it is completely attractive. So, you might think, okay, the both of them can possible, actually no. So, you have to remember that the distance up to 0.8 femtometer, it is attractive. Okay, between 0.8 till 0.12 femtometer, okay, it is both attractive and repulsive. From not 0.12, sorry, 0.12 is smaller than 0.8 itself. So, it is 1.2 femtometer, and from 1 point greater than 1.2 femtometer, so if the distance is r is less than 0.8 femtometer, then it is attractive. If it is between 0.8 to 1.2, it is both attractive and repulsive, but slowly attractive force decreases and repulsive force increases, and if r is greater than 1.2 femtometer, it is only repulsive. Okay, so you have to remember this. Maybe next year they will say repulsive for distances greater than 1.2. So, you have to be careful about that. Okay. So, now from this year only this is the correct answer. Next question, the nuclear radius is of the order of. So, what is the order of nuclear radius? Nuclear radius is of the order of 10 to the power minus 15 meter. Okay, it is of the order of femtometers, right. That is why distance is very small, everything is compact together in this radius. So, that is the formula for nuclear radius. Now, Chadwick discovered photon, proton, electron, neutron. Chadwick discovered neutron. Okay. The ratio of nuclear mass to the nuclear volume is called nuclear density, obviously nuclear density. Next question, the ratio 1/12 mass of C12 atom is 1 atomic mass unit, or 1 U or 1 mu. Most common books they generally mention it now as 1 U. Okay, so 1 U can also be written. AMU was old notification, old symbol. Okay, neutron was discovered by James Chadwick. Okay, same question, just form changed. So, Chadwick discovered neutron, neutron was discovered by Chadwick. Nuclei with same atomic number are called, this is the same question. Okay, it's same question as first one. Now, they have changed the language, so that now it appears to be slightly difficult. Nuclei with same atomic number, if the atomic number is same, then it is the same element, only it is an isotope of the element. Okay, isotopes, same atomic number means they are isotones, right. The equivalent energy of mass defect is so mass defect and equivalent energy, what is the relationship? So, we know that binding energy is basically mass defect times c square. So, this is the equivalent energy of the mass defect. So, that is basically nuclear binding energy, not anything else. Question number 12, nuclear fission is a process where two light nuclei combine to produce a heavy nucleus, two heavy nuclei combine to produce even heavier nucleus, one heavy nucleus breaks into one or more stable nuclei, none of the above. So, nuclear fission is breaking of nucleuses. So, breaking of nucleus, so one heavy nucleus breaks into one or more stable nuclei. So, most of the cases you get one stable nuclei, some cases more than one nucleus, some cases you get maybe only one, that is also part of fission. Fission mainly when nucleus breaks apart, that is called fission, right. Fusion is when lighter nuclei join together and forms heavier nuclei, that is what is happening in our sun. Hydrogen is continuously fused into helium, and that process a lot of energy is being released, and we are getting the light and warmth from the sun, that is the source of sun's energy. Now, once all the fuels of hydrogen is burned, then helium will start to fuse, helium will finish, then newer material will form, unless and until everything is fused to till the stage of iron, right. Once iron is formed inside the core of the star dies slowly, and then there will be a red giant, and slowly we will all die. By the time it happens, we will die anyway, right. So, that is the process. An alpha particle is hydrogen nucleus, helium nucleus, hydrogen atom, helium atom. Alpha particle is helium nucleus only. So, doubly positive helium ion. So, doubly positive helium ion means you have taken away the electrons that is orbiting around the helium, right. He 2 plus, helium alpha particle is basically He plus 2. Plus 2 means you have taken both the electrons from the helium, that is basically only the helium nucleus is left. So, only helium nucleus is left means it is helium nucleus only. Next question, the nuclear force between neutron is more than that between proton neutron. Proton neutron is more than that of between neutron comma neutron proton are same, neutron is 0, it will be proton. Okay, neutron and neutron proton are same. Now, we know that in case of nuclear forces between neutron proton and proton, all three are same. all three are same. Okay, that is the property of nuclear force, that nuclear force between two neutrons, two protons, or a proton and a neutron are same, right. So, this is the answer. Next question, the energy equivalent to a substance of mass 1 gram is. So, what is the energy equivalence of mass of 1 gram? You can remember it, it is 9 times 10 to the power of 13 joules. So, if you destroy 1 gram of mass, you will get this much amount of energy. Okay. You can convert it, 1 gram is equal to 10 to the power of minus 3 kilograms. Now, the energy equals to mc square. So, if you are destroying 1 grams of mass, that is 10 to the power minus 3 kg, c is 3 times 10 to the power of 8. Sometimes I am too fast. 10 to the power of 8 kg. Now, it is c square. So, you have to square it. 10 to the power of minus 3 times 3 square is 9 times 10 to the power of 8 square is 10 to the power of 16. So, you will get 9 times 10 to the power of 13, right. This is the mass equivalent of 1 gram. So, if you destroy 1 gram, you get so much energy, right. So, answer is this. You can remember it, you can calculate it, no matter how you think about it. The problem is solved in your textbook. So, basically it can come as a memory based question because it is already solved in your book, right. Now, let us solve numerical for 3 marks question. Find the energy equivalent of one atomic mass unit, first in joule and then in mega electron volt. Given you, this is a specific problem, okay. The value that will come out will be specific. So, you have to use the calculator to solve this question, okay, and exactly up to this decimal. You are allowed to use calculators for your PU board exam. The smaller versions, so you can use non-scientific calculators, and only multiplication that you have to do. Okay. So, 1 u is equals to given already. So, first of all, what is the mass? Mass is 1 u, that is 1.6605 times 10 to the power of minus 27. So, if you see here, C's value is given exactly. It is not the 3 into 10 to the power 8 that we use approximate value. Here it is given up to 4 decimals even after 2. So, you have to put the values in exact value, right. Now, so this is the mass. Now, what is the energy equivalent? Energy is basically from Einstein's equation. We know that energy is equals to mc square. So, you have to put the m, you have to put the value of m is this, c's value is this, square it. So, when squaring it, there is a trick. What to do? 1.6605 times 10 to the power of minus 27. So, what you have to do, using your calculator, you just square this number. You can square this number in your hand, right. So, this square of this number will be 2.9979 whole square, and square of this will be 10 to the power of 16, right. So, approximately you will get this as 14.92 times 10 to the power of minus 11. Okay, I remember this value because I don't have the calculator. So, you can use the calculator to find the exact value. This is the value in joules. Okay, 14.92 into 10 to the power of minus 11 joules. So, this is the energy in joules. Now, you have to, this is not done, first in joule and then in mega electron volt. The problem is simple. Only thing that you have to do, you have to use the formula and apply your mathematical aptitude. Okay, I have seen students, they are solving mathematics with abstract numbers x, y, z, and sometimes when it comes to put the values, they are making mistakes. So, don't do that, practice this kind of problems, because even if you miss one decimal, 1 0, one number, your answer will be different. Okay. So, you will get a different value. Now, next problem, next answer I know already, okay, because that is the most common thing that is used in solving MCQs for KCET, right. So, that value we will soon come after, that energy in MEV. So, energy is mc square, that is in joules. Now, if you want to convert it into EV, MEV will come later. First, let us convert it into EV. We have to divide it by the charge of an electron. Okay, that is why this charge of an electron is also given a more accurate form. Okay. So, what will be the answer? We know that this is the value. So, 14.92 times 10 to the power of minus 11 by 1.6 times 10 to the power of minus 19. Okay. So, it will come out to be 9.315 times 10 to the power of 7. 8. You can do this calculation. If you put the exact values, you will get exact the answer that I am writing here. Okay. There will be some more decimals, but you can ignore that. You can keep it only up to this value. Okay. So, it will be 9.315 into 10 to the power of 8 EV. Now, what is MEV? 1 MEV is basically 10 to the power of 6 EV. So, if you take 10 to the power of 6 from here, then you can write this as 9.315 times 10 to the power of 2 MEV. So, basically you are reducing it by 10 to the power of 6, right. That is how you can convert it into MEV. Now, you can take 10 square means 100. So, you can take this as 931.5 MEV. This value is very important. Okay. Even if you are preparing for KCET, you are not preparing for KCET, you are only preparing for board also. If you remember this value, a lot of your problems will be solved. Next, we will see few more problems, and there you have to use this value. Okay, this value is very important. Any competitive examination, there will be a problem where you have to use this value to solve, to find binding energy or binding energy per nucleon or whatever it is. Okay, you have to use this value. Sometimes for competitive examinations, we can approximate this to be 930, so that it gives us a good practical value. Okay, because 930 is sometimes easier to cancel, etc. Okay, otherwise, if it is already given in the multiplier of 931.5, then you can use this value as well. Okay. So, this is a very important value, and we also have calculated in terms of joules, which is hardly used. So, if you destroy one atomic energy, one U energy mass, then you get this much amount of energy. It is also a very high amount. In terms of joules, maybe it is very small, but you can imagine that one U itself is very small. One U itself is like 10 to the power of minus 27 kg. So, the huge amount of energy is released. Next question, define binding energy and mass defect. Write the relationship between them. First, we will define mass defect, then we will define binding energy. The difference of mass of a nucleus and its constituents delta M is called the mass defect. So, mass defect means what is the nucleus? Basically, what is the nucleus? Nucleus is the center or core of an atom, right? And what inside the nucleus? Nucleus has mainly two particles, that is proton and neutron. Okay. Their number, their distributions may vary, but only these two particles, they are reside inside the nucleus, right. Now, what happen is, if you suppose you have say 5 protons and say 5 neutrons inside a nucleus, certain nucleus you have 5 protons and 5 neutrons. Okay. Now, if you calculate the mass of this in using some device, okay, mass of this entire nucleus, say that mass is x, mass of the nucleus itself. Now, you remove the nucleus and you measure the mass of 5 individual protons, okay, and 5 individual neutrons. 5 protons 5 neutrons. Now what do you expect? In our day to day life, if you suppose if you purchase 5 packets of biscuits and each biscuit weighs say 20 grams, if you weight them together you will get 100 grams, right. So individually the mass of entire biscuit is equals to the total mass, right. But in case of nucleus there is a difference in the mass, okay. Difference in the mass, say y. So this y is much more than actual mass of the nucleus. In case our day to day life it is actually ulta. What is the meaning of that? Suppose you went to a shop, you buy a biscuit packet, okay, there are say 5 biscuits inside the packet, each weight 20 gram, you know that the weight of the biscuit packet should be 100 grams, but there is a plastic covering outside, right. So actual weight may be slightly actual weight of the biscuits may be slightly less than that of the entire packet, but here in nature it is exactly opposite. This is the biscuit with the packet and its mass is less than that of the individual biscuits. Isn't it interesting? So actually what happens, this extra amount of energy, this whatever the energy, that is the difference, energy difference, that is called the mass defect, okay, mass defect. So the nucleus has less mass compared to the mass of its individual particles, okay. And if you see here, this is the mass of proton, this is the mass of neutron, this is the mass of the nucleus itself. So if you add the mass of proton plus mass of neutron and subtract it from and if you subtract that from the mass of the nucleus, you get a value which is actually greater than 0. So that is why it is called mass defect, which is peculiar. If it was in the opposite side, that okay, individual mass say more than that, individual mass is less than that of the total mass, maybe you can accept that, somewhere we could have explained it. Now what is the binding energy? The energy required to separate a nucleus into its nucleons is called the nuclear binding energy. So there is all the nucleons sitting together inside a nucleus. Now you want to break that nucleus, you want to take out all the biscuits that is inside this, right. So you can compare this to be a packet of biscuits. So you want to tear that packet and you want to take all the biscuits out. So the energy that you have to supply to do that, that is called nuclear binding energy, right. And it is given by EB equals to delta m c square. What is delta m? Delta m is same as this mass defect, right. So delta m is mass defect. Now in some time they will only ask you mass defect, write its formula and explain the terms. So mass defect, its formula and explain the terms means Z is the atomic number, okay, MP is the mass of proton, A minus Z is obviously number of neutrons, and Mn is the mass of the neutron, MP is the total mass of the nucleus, right. So this is how you can remember it, and you can if the question only comes for the mass defect, then you have to write this much, okay. This is also very common, defining mass defect 1 number, formula 1 marks, explaining the terms 1 marks, okay. That is how you can get full marks. And here they have directly given you mass defect and binding energy. This formula is not necessary in this case, okay, but you have to mention this delta m here, okay, and then only you can use this here, okay. This is the relationship between mass defect and mass defect delta m and binding energy, okay. Now write 3 features of nuclear force, very common and most asked question from this chapter, Okay, this is one of the star questions. Okay, the most commonly asked question from this chapter. I know many students know this, they study it, but still they cannot remember it. So, first of all, nuclear force is a much stronger than the Coulomb force between the particles, between the charges and the gravitational force. So, inside the nucleus, as we have seen, there is a proton, there is another proton. Two protons are very close to each other, and Coulomb force is inverse square law, we know that. So, if the distance is less, the repulsion force becomes very high, right. If the distance is small, the repulsion force is goes almost up to infinity, but the nuclear force is even bigger than that force. Okay, nuclear force is so strong, okay, it can withstand that Coulomb force. Okay, and there is also some gravitational attraction force which is keeping it close. They are trying to keep it close, but the gravitational attraction force is like negligible. So, if you consider the entire earth to be nuclear force, okay, then gravitational force will be of the size of a sand, maybe, okay, even smaller than that of sand, or maybe size of an atom, okay, to understand the scale of the force. Okay, and electric force may be size of a moon. Okay, if earth is the nuclear force, electrostatic force or Coulomb force is of the size of the moon, and gravitational force is size of a sand. So, there is a huge difference between them. The nuclear force between two nucleons falls rapidly to 0 as their distance is more than a few femtometer. So, as I said in the past also, as the distance increases, as it goes beyond 1.2, 1.5 femtometer, the nuclear force becomes 0. There is only repulsive force now. Okay, only when they are very close, the force is very strong. When they are far apart, the force, there is no nuclear force. Nuclear force is a short range force. So, you can mention that nuclear force is a short range force. Also, don't only mention the headings, explain it little bit, okay, that makes a good communication with the teacher. I have seen students even after repeated saying that don't write only the headings, okay, even maybe you will get marks, but they will know either you have copied from someone or you are not super good student, you have only remembered small points. So, if you want to score well in your PU board, try to write as detail as possible, not super detail, but at least bare minimum is to write a complete sentence, okay, that is very important. Next is the nuclear force between neutron-neutron, proton-proton and proton-neutron and proton-proton is approximately the same. The nuclear force does not depend on electric charge. Okay. So, obviously, nuclear force does not depend on electric. I have seen the student write this line, but when I ask them what is the meaning of this line, they are not able to explain. Okay. So, the meaning of this line is that no matter what type of particles you choose, the nuclear force between all types of particle is same, and obviously the particle means neutron and proton only. Okay, inside nucleus only neutron and protons are there, and neutron means two neutral particles, whereas proton means two positive particles, whereas neutron proton means one positive, one neutral particle. So, nuclear force by default it is independent of the nature of the charge, right. Now, next question, calculate the mass defect and binding energy of 7N14. Okay. This question came a lot of times also. This is also a very super important common question, came in I think last year, I think 2024 it came. Okay. Calculate the mass defect and binding energy of N714 given that the rest mass of nitrogen nucleus is 14.00307 U, rest mass of the proton is this U and mass of neutron is this. So, rest mass of neutron means when you take the neutron alone, not a part of nucleus. So, if you take the neutron alone, its mass is this. Okay. When you take the mass of neutron, its mass is this. Okay, this is also a common question in KCET preparation. Okay, those who are preparing for KCET, this question I think almost came twice in KCET exam. So, how to do that? First, you have to find the mass defect. Okay, how to find mass defect? As you can see, N n, basically right now we write it like the symbol is like this. So, n 147 has how many protons? So, it has 7 protons. So, number of protons is 7. How many neutrons? Number of neutrons is basically mass number minus atomic number, that is 7 again. Okay, that is the beauty. Many of these lower up to calcium, most of them have equal number of proton and neutron, primary element. Okay, there are isotopes. So, but for a primary most common element, they have almost same number of protons and electrons. Sorry, protons and neutrons. Protons and electrons are always same. Anyway, so 7 protons, 7 neutrons. Now, what is that? Mass of this constituent particle. Mass of this constituent particle is 1.00783. Now, in this case, I can do a small approximation because I do not want to do all the calculations again and again. So, I will be doing some approximation. Okay, so times 7 plus 1.00867 times 7. So, we multiplied number of protons with mass of proton, number of neutron with mass of neutron. Okay, and it will be coming out to be, let us see, 1.05 almost. Okay, 5. So, this will be almost 1.00055 plus it will be almost 1.06. Okay, almost. Now, if you add these two, you will get, sorry, not 1 point, my mistake. They will be 7 ones are 7, right. So, first term will be 7, 7 ones are 7. So, do not focus only on the decimal part, focus on the first part as well. So, it will be 7 and 7. So, it will be 14.115 approximately. This will be the value of the rest mass of the nucleons, right. Now, what is the mass defect? So, mass defect delta m is basically rest mass of the nucleons, that is 14.115 minus the mass of the nucleus 14.003. Okay. So, it will be approximately 0.112. Okay, 0.112 will be the rest mass. This is in terms of U, obviously. Everything is calculated in atomic mass unit. Now, we know that is what I said in the first problem that we have solved. 1 U is basically 931.5 MeV. So, we will calculate the mass defect in terms of MeV. So, 0.112 times this is mass defect, okay, and binding energy. So, my mistake. This is the binding energy. To convert mass defect into binding energy, we have to multiply with this 931.5. So, it will be 104. I think yes, that is the answer. I solved this question in our KCET class. It is 104 MeV approximately. You can check with your calculators and let me know how close I was without using calculator. How close I am without even using calculator. What was the final value? Okay, if you are watching this video. So, this is the very common question, very important question. You need to remember how to solve it. This is the mass of the nucleons. This is mass of the nucleus. Nucleons means, what is nucleons? Nucleons means the particles which constitute the nucleus, right. So, nucleons means for example, organs. Organs means the composite our body. Liver is an organ, right. Kidney is an organ. So, they are basically part of us. Similarly, nucleons are part of nucleus. Okay. Now, next question, find the another binding energy question. This question came in 2023 exam. So, that is what I said that one binding energy question is coming almost every year, that is why we are solving this many questions. Find the binding energy of an alpha particle from the following data. Now, it is an alpha particle. What is alpha particle? Alpha particle is helium plus 2, right. Mass of helium nucleus is 4.001 U. Rest mass of proton approximately 1.007. Rest mass of neutron is 1.00867. So, let us calculate that mass of the nucleons first. How many? What is the helium? What is alpha particle? Alpha particle is basically 2 4, right. It is easier. 2 4 means 2 protons and 2 neutrons. 4 minus 2 neutrons. So, what is the mass? Mass of the nucleons. Mass of the nucleons is 2 times 1.007 plus 2 times 1.0087 or better let me keep this as 0.009. Okay, you have calculator in case of exam they give you longer values, do not worry, just use the calculator, but calculate it properly step by step. Okay, so, what is the mass of the nucleons? 2.014 plus 2.018, right. So, it will be 4.032, okay, right, 2232, yes, 0.032 U. And what is mass defect? Mass defect is original mass, total mass minus the measured mass, right. So, it will be 0.3031. This is the mass defect. Now, what is the energy? Binding energy? Binding energy is 0.031 times 931.5. Okay. It will be about 27, okay, about 27, 28 MeV, you can check it exact value, okay. Yes, about 21, 27, 27, between 27, 28, okay, for safe I am writing it approximately 27.5. Again mention in the comment below how far off I am from the actual answer. Use your calculator, calculate this exact value and mention in the comment below what is the exact value of this calculation. Now, once more there is a part where they ask you, sometimes they give you the mass defect. There is once I have seen this question in one of the pre-board exam paper, that they have given you this mass defect directly, and sometimes in competitive exam as well they will ask you find the nuclear binding energy per nucleon, which is very important term, binding energy per nucleon. Binding energy per nucleon is binding energy divided by the number of nucleons, that is the mass number. So, mass number in this case is 14, okay. Mass number is 14. So, it will be 104 divided by 14 per nucleon, okay. Whatever it will be 0.9 something, okay, you can calculate it and you will get the answer. So, that is also sometimes they ask you to find. So, this you should know, binding energy per nucleon means total number of nucleons present in that nucleus. So, total binding energy that you have calculated divided by number of nucleons present in the nucleus. So, that is also possible. In this case only I have seen, if they ask you for the same question here as well, what you have to do, binding energy per nucleon, EB by 4 will be the answer, because in this case nucleon is 4. So, 27.5 divided by 4, okay, and it will be about 6.1, I think, right, or I made some mistake, like that. Okay, it can vary, this binding energy per nucleon for lower molecules varies, but as you go higher and higher binding energy curve, the value becomes constant almost. Okay. So, we have reached the end of our lecture today, and as you know that we have launched PU2 Success Blueprint test series, where we are trying to help you to achieve the best possible marks in your PU exam, and you get a lot of things only for the price of 599, and me being a Santa, I am giving you a special offer. Use my code SAM100, okay, and get a special 100 rupees off from this price, and everything is available for 499. Okay, don't forget to apply the coupon code SAM100 before you click on the purchase button. The link of this is given in the description. You can purchase from there. Okay, once you click on that, they will redirect you to purchase, and before purchase you have to apply the coupon code SAM100 to get an special 100 rupees off, right. If you have not yet subscribed to our channel, don't forget to subscribe to our channel. We will be coming back with more informative videos, and next week I will be continuing with our Brahmastra series in next Tuesday. Till then, bye. I will be back with a new chapter.